PID 38, the title of our paper is Study of Seaweed Powder Processing Parameters Using Dry Mill Blender. Problem statement. The process of producing powder seaweed facing major fundamental problem, especially the loss of nutrients due to high temperature. Actually, this problem is not only limited to seaweed, but all organic material, especially in the food industry. Spray drying, which is a common technique used, has limited use, especially for organic products in the past because of the high temperature used during the process, which normally would generate high viability losses. In spray drying, the inlet temperature can typically be at 120 to 160 degrees Celsius and 50 to 80 degrees Celsius at the outlet, which may damage the nutrient in the seaweed or any organic product, as previously reported by Champagne and Fastier. The objective of our project is to determine the factor that will most influence the seaweed powder size when milled using dry mill blender. Three parameters used in this experiment were blending time, whereby it is the duration of the milling time, raw material treatment, the temperature that we apply during drying the seaweed, and the milling speed. Methodology. The experiment was designed using the two-factorial method with the assistance of Design Expert 6.0. The experiment is shown as in Table 1. The control factors were blending time, raw material treatment temperature, and mill speed, with the powder seaweed weight as its response output. The raw seaweed were initially cut into smaller pieces and then dried in an oven at 28 degrees Celsius and 175 degrees Celsius for 20 minutes. 10 grams from each batch of dried seaweed were then milled at 50 to 60 Hz with blending time of 30 to 60 seconds. The milled seaweed were then sieved using the 250 micron size siever and weighed using the digital weighing scale. Results and discussion. From the experiment, we found that the highest percentage of acceptable seaweed powder produced was at 60-second blending time, 175 degrees Celsius treatment temperature, and 50 Hz of mill speed. We can observe that from the experiment that all seaweed treatment temperature at 175 degrees Celsius constantly showed the range of 10 to 55% of weight percentage acceptable powder size. This result also is in agreement with the ANOVA results, which showed the temperature factor is the only one with the p-value of less than 0.05. The other two factors, the blending time and the mill speed, are insignificant. The results can be explained whereby naturally raw seaweed showed an hydrophilic-like behavior, whereby with its polysaccharide molecules, the higher drying temperature may have removed more moisture, which is observed by its brittleness character compared to the lower treatment temperature. This may have boosted up the process of crunching and pulverizing it into fine powder. This also signifies the importance of storing the raw seaweed in a dry environment in order to reduce moisture presence before processing, which will significantly increase milling time and temperature to obtain the desired powder size. The results also showed that the mill speed and blending time were inadequate to affect the powder formation process. Future study may expand the scope to higher mill speed motor and alternative reinforced mill blade material. It is shown, in conclusion, it is shown that treatment temperature plays the most important role in the formation of seaweed powder using dry mill blender. Our results using the two-factorial design experiment give a mathematical expression for the seaweed powder accepted can be written as powder accepted is equal to minus 0.52869 plus 0.023435 multiplied with the seaweed treatment temperature. We would like to acknowledge to the Malaysian Technical University Network Grant MTON 2019 under the title of Manufacturing of Seaweed Powder Processing for Soap, Food and Cosmetic for their financial support. Thank you very much for your attention.